find the area between the two curves, x squared minus 3x plus 2 and minus x plus 2, by integrating with respect to x and then with respect to y. First, let's sketch our picture. So if I look at my two functions, the first function is a parabola that faces up, since the coefficient on x squared is positive. My second function is a straight line with intercept 2 and slope minus 1, so it goes down like that. To get a better idea of what the parabola is doing, let's also notice if I put 0 in to the equation, 2 comes out, so our graphs are going to meet at the point 0 up 2. To get a little bit more in the parabola, let's also factor the equation and see what the zeros are. So when I factor this, I'm going to get x minus 1, x minus 2. So we have 2 more points. And we notice we've also found the other point where the two graphs meet. Okay, I can draw on the parabola and then shade the region in. Okay, to verify the points of intersection, we just set the two equations equal to each other. And then we know we get x squared minus 2x when I push everything over. And so that's going to give me the points that I've already found. X equals 0, x equal to 2. So here's our picture. When I integrate, the limits of integration are going to start from x equal to 0 and go over to x equal to 2. So for x, we have our function for the area given by integrate over your limits, and then the rule is take the top function, subtract off the bottom function. We put our two functions in. The top is the line, the bottom is the parabola. We crunch it down, and then I wind up taking the antiderivative. So we add 1 and flip it over. The 0 does nothing when I put it in, so we just stick the 2 in. I have minus 8/3 plus 4 gives me 4/3. Okay, 2 points to make here. First, the formula, okay, probably better just to remember the pictures because they'll make more sense than remembering another formula. So notice here, if I have a top and a bottom, well, if I just integrate over the top, that gives me this region here. If I just integrate the bottom, that gives me that region here. So we get top minus bottom because it's basically taking this big region and yanking out the bottom part. So pictorially, this is what our equation says. Another point, sometimes this bothers students, so I'll bring it up. Is there a problem going beneath the x-axis? So the answer is not at all. Formula top minus bottom still works. Let's take a look. Well, if it's below the x-axis, okay, surely you'll agree if I just take the region and shift it up until it's above the x-axis, the area between the two curves won't change. Okay, the curves themselves will change, their equations will change by adding a constant, but the actual area won't change. So if I shift up by a constant c, we just add a c to each of the functions. And now when I take top minus bottom, you'll notice the c's are going to cancel out, leaving me with the original top minus bottom. So going below the x-axis, no effect at all. Okay, same formula. Now let's compute the area with respect to y. So I still have my sketch. Let's take a look at what's happening here. So remember, we have 2. Our variable is now going to be y, so we're going to be interested in the region from the top point here all the way down to the bottom of the parabola, which we'll have to figure out at some point. First thing I want to do, well, we're going to get rid of x in all of our equations, so I'm going to need to put the functions in terms of y. The easy one, for the line, y equal to minus x plus 2, we just want to isolate x. So I put x on the other side, bring the y to the other side. Our top function, well, now it's going to be our right function, is 2 minus y. For the x squared minus 3x plus 2, we're trying to isolate x, but there's a square on it, which is going to complicate matters. So the trick we're going to need to get out of this is going to be completing the square. So if you don't have that at your fingertips, the rule here is x squared plus 2ax equals x plus a squared minus a squared. So the idea is you look at what's in front of x, you take its half, then you're going to have x plus that half, square that, and then subtract off the square of what you got for your a. So in this case, completing the square gives me y equals x minus 3 halves squared, because half of minus 3 is minus 3 halves. I'm going to square that minus 3 halves. That gives me 9/4, which gives me minus 9/4 on the outside for the minus a squared term. Note, no matter whether I have a positive or negative in here, this is always a minus sign. Okay, you'll never get a negative number when I square a. So this minus sign, there's no chance of getting rid of it. Okay, and then I'm going to add the 2 that we had from before. So this collapses to x minus 3 halves squared minus 1/4. I can push the quarter to the other side. That's going to give me this equation. And now I can take the square root of both sides, leaving me with x minus 3 halves equals plus minus square root of y plus 1/4. In this case, we're absolutely going to need both solutions for the square root, the positive and negative. Remember, square root only spits out positive numbers. So we're going to need both. So the solutions to this are going to be x equals 3 halves plus or minus square root of y plus 1/4. Now, what's going on here? Well, if you notice, when I flip things from x into y, the parabola is no longer a function. It's not a function of y. It's actually the gluing together of 2 functions. On this point past the bottom of the parabola and above here, it's going to be the function 3 halves plus square root of y plus 1/4. And for the lower part, this function here is going to be 3 halves minus square root of y plus 1/4. The best way to figure out which branch goes with which function, just stick 0 into each and see what comes out. If I stick 0 into 3 halves plus square root of y plus 1/4, that's going to give me square root of 1/4, which gives me a half, which gives me x equal to 2. So there I'm looking at the point 2 comma 0, and that's going to be on this branch here. So that branch goes with this function. If I put 0 into the other one, I'm going to get 3 halves minus square root of 1/4, which is 3 halves minus a half, gives me 1. So we're looking at the point 1, 0, which is on the lower branch. So that means that's going to be the function of this piece here. So now the only thing I'm missing is the lower limit. Okay, that's going to be this bottom point on the parabola. If you're thinking about what we're doing, we're going to integrate in y. So I'm going to take all of these horizontal slices as I go from the bottom part up to 2. Okay, well note, this is just the bottom of the parabola. So I can get that by just figuring out what the critical point is in terms of x, and then I'll just plug it in to my formula for y. So critical point is going to be at x equal to 3 halves. Take the derivative, set it equal to 0. I get 3 halves. Plug that into the function, so that's x squared minus 3x plus 2, and that gives me minus 1/4. If you're nimble, you'll notice that's what you would expect when you complete the square. That's why this y plus 1/4 comes out. I'll let you sort that out. Next, we have everything we need to do our area. We just have to note that this is going to turn into 2 area computations. There's going to be this top part, and there's going to be this bottom part. Okay, this happens because now we're going to go from top minus bottom to right minus left. Okay, you can draw the picture for that, same as we did for top minus bottom in point number 1 from before. Okay, right minus left. Well, if we notice, as we let our y change, when I hit the x-axis, the right function is going to change from straight line to far parabola arc. So we're going to need 2 integrals to get to our answer. Okay, we just follow our nose. So this looks messy, but it's not bad at all because integrating square root of y plus 1/4, a u substitution takes care of that nicely. So I take my antiderivative, a half y minus a half y squared, plus 2/3 y plus a quarter to the 3/2. So that's going to be gotten just by substituting out the y plus a quarter. Follow your nose. What comes out? It's going to be 14 over 12. One thing to note is you need to be careful. This 0 here is not going to contribute to these terms in the front, but this last term, the 0 goes in, and 0 is not coming out. So you just need to be careful with that, or you'll lose something. We'll go to the bottom part. Well, now note this is going to be right minus left. So we already saw that the right has the plus sign, the left has the minus sign. So that's going to collapse nicely to this 2 square root of y plus a quarter. Again, it's a u substitution. You work things out, and you notice you wind up with 1/6. So the total area of this region is going to be 14/12 plus 1/6. Put everything over a common denominator, and I get 4/3, and that agrees with the answer we got when we integrated with respect to x.